this is the first type of problem from section 5.2. It says, decide whether the function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. So most things are going to be polynomial functions. You're just looking for weird things like negative exponents and exponents that aren't numbers, weird things like that. So let's take a look at the first one, a. And it's h of x equals x to the fourth minus 1/4 x squared plus 3. That's something that is a polynomial function. It doesn't have any weird exponents. It's already in standard form because the highest exponent is first, then the next one, then the lowest exponent. So it's already in standard form. We need to state its degree. The highest exponent gives the degree for the function. So the degree for a is 4. It's a degree of 4. The type, you don't need to say anything about that, although you know what this is going to look like after you graph it. And the leading coefficient, so you don't need to give the type. And the leading coefficient is 1, because the leading coefficient is the coefficient in front of the leading term, and here that term is x to the fourth, so the leading coefficient is 1. Okay, b. First, we'll see if it's a polynomial function. Looks like it is. There's no weird exponents or anything like that. There's a square root, but that's not like a strange exponent or something else. Let's go ahead and put that in standard form. That means standard form is putting the highest exponent first. So that means we're going to write pi x squared. 7x is the next one. It's the exponent of 1. 7x plus 7x minus square root of 3. Square root of 3 doesn't have an x term, so that's the lowest. So that's in standard form. The degree is 2. Degree is, once again, the highest degree, and that's a 2. And the leading coefficient is going to be pi. That's the coefficient in front of the leading term. Let's look at those other two. So c, it's 5x squared plus 3x to the negative 1. That's got a negative exponent. This is not a polynomial function. And d, it's x plus 2 to the x. Okay, that exponent is not a number, it's an x. That's also not a polynomial function. The next important thing from this section is called end behavior of polynomial functions. And what end behavior is what will happen as this function continues on forever towards negative infinity and positive infinity. So that means like over here and up here. What will happen to this polynomial if we just leave it alone and it goes on toward infinity? So what it is the first one, if it has an odd degree, that's not a highlighter. If it has an odd degree, that means if the highest degree of this polynomial is x cubed, x to the fifth, x seventh, that's odd, and the leading coefficient's positive, so that would be something like an x cubed positive x cubed. It will look something like this. It starts over here, low, starts at negative infinity, and makes this shape, and will continue on towards positive infinity. If the next one, so let's say the degree is odd, like x cubed, but the leading coefficient's negative, so that would be something like, if we had x, let's say we had maybe 2x cubed, but it was a negative 2x cubed. That's an odd degree of 3, and a leading coefficient of negative 2, that's negative. It will start high over here and make this shape and continue on towards negative infinity. Let's look at the bottom two. If the degree is even, like x squared or x to the fourth or something, and leading coefficient is positive, it makes this w, a w-like shape. And it will continue on towards a positive infinity in both directions. It'll keep going positive. If the degree is even, but it has a negative leading coefficient, it'll continue on towards negative infinity in both directions with this shape. Now this will make a little more sense when we look at a couple examples. Alright, so you're going to see questions like this. It says describe the end behavior of the graph of the polynomial function by completing these statements. F of x goes to blank as x goes to negative infinity, and f of x goes to blank as x goes to positive infinity. And what I want to know is what will happen to the function as x gets smaller, infinitely smaller, and what will happen to the function as x gets infinitely larger. So we can look at it and we refer back to that table from before. So like I said, we're referring back to this table, and we're just going to look at this equation and see what we have. So we're looking, is it in standard form? The answer is yes. The leading term has the highest exponent. That's how we know it's in standard form. It is 7, which is odd. So the degree of this polynomial is odd. So it has to be this one or this one. The leading coefficient here is a 1. That's positive. So we have this one. So we know as x goes to negative infinity, f of x goes to negative infinity. So the first one we put a negative infinity in for the question mark. And f of x goes to positive infinity as x goes to positive infinity. And if you don't know just by looking at it, of course you can use this chart, but you can always, plug this into your calculator. To the 7th plus 3x to the 4th minus x squared. And you'll see something like we'd expect, right? This graph that looks sort of like this. So as x goes to negative infinity, as x gets smaller and smaller in the x direction, the function also gets smaller and smaller. As it gets larger, the function also gets larger. That's all this is saying. As x gets smaller, the function gets smaller. As x gets larger, the function also gets larger. Okay, let's look at this second one. So we have negative x squared plus 4x cubed minus 3x. And we're going to look and see, is it in standard form? The answer is yes. These exponents descend from greatest to smallest. We see that it has an even degree. The degree is 6, which is even. So it has to be one of these two on the bottom. And the leading coefficient is negative 1. That's negative. So it's even and negative. So it's this one. The graph should look something like this when we plug it in. Let's go ahead and try. So negative x to the 6th plus 4x to the 3rd minus 3x. And it looks pretty much like that. It comes up, it makes a turn, it comes down, makes another turn, and one more turn, then it continues on. So what's going to happen to this graph? The parts we can't see, infinity. So this chart will tell us as x goes to negative infinity, as x gets smaller and smaller, the function also gets smaller and smaller. It's decreasing forever. As x increases, as x gets larger, the function still decreases forever and ever. As x gets larger, the function of x, or the y values, gets smaller. I would really suggest writing this table down in your notes.